Thanks, Paul. Kia ora and good afternoon, everyone. I hope everyone is having fun at Sydney Summit. My name is Deepika Kumar, and I'm a solution architect at AWS. I'm here with Nick Broadchoy today to talk you about how we build defense in depth into our multi-tenanted AI services. And by end of the session, you will have an understanding of how to apply these principles into your next-gen AI application. As Paul mentioned, this is a level 300 session, so we are assuming you have an understanding of security fundamentals and some core concepts of multi-tenancy and generative AI. So what you can expect to hear from us in the session today. Just a minute. Sorry, my clicker is a bit off the track. Thank you. So first, I will start with the concept of multi-tenancy in generative AI, the benefit it brings in terms of resource management and scalability, and the challenges of multi-tenancy in generative AI application. Second, we will talk about the layered approach to security within a multi-tenant environment. And then we will deep dive into the security fundamentals that forms the foundation of a secure AI service. And finally, Nick will take us through to the under-the-hood security architecture of one of our multi-tenanted AI service and its demo. So before we deep dive into multi-tenancy, let's have a quick look at our experiment with generative AI. I think we don't need to define it. We all know its impact. Instead, that was all over in the keynote session today. So please raise your hand if you are using any sort of generative AI or either for content creation. It's good to see so many hands in the audience. You know what? Even my 6-year-old uses it as her homework assistant. Isn't that humorous? But it underscores, really, but it underscores how generative AI is changing the way businesses operate, what they build, and how they build. Now let's understand the synergy between generative AI and multi-tenancy. Generative AI, which powers the services from content creation to code generation, thrives on the scalability and efficiency offered by multi-tenancy. This architecture enables a single AI model to serve a diverse array of users and organizations, customizing its output for each without requiring a separate instance. Imagine if each user required a separate instance and the inefficiencies without that. It would require higher cost, wasted resources, and less time on machine learning innovation. And that's the operational hurdle we want to overcome with multi-tenancy. And this approach is just not about efficiency. It's a testament to frugal architecture core ideals, which minimize the resource consumption by sharing the resources, minimizing the operational cost and environmental footprint. So as we have seen, multi-tenancy, yet efficient, but brings its own set of data security and privacy challenges, especially critical when generative AI is handling with your sensitive data or your proprietary code. We must ensure these generative outputs are not only customized, but also securely delivered to each tenant, mitigating any risk of data leakage and unauthorized cross-tenant access. So to counter against these challenges and navigating these complexities of multi-tenancy in generative AI, while building our multi-tenanted AI services, we have deployed a foundational strategy called defense in depth. Let's see how we are managing these complexities. I will just use a simple analogy here. Imagine our AI service as a castle. The goal is to protect our treasure. In our case, the treasure is customer data and their privacy. So how do we make sure our customer data is safe and secure? With the layered approach to security. Let's break it down by layer, just as castle defenses. So first, our castle have got outer walls, which are tall and strong. In our world, it relates to securing the physical locations where our customer data is stored. That is our data centers. Just as you would not allow anyone through your castle, we control access to our data centers. Then the castle have got moats around it, which controls who can approach towards the castle. This layer represents our network security, firewalls, intrusion detection system, which controls and monitors any incoming and outgoing traffic to and from our network. Then we have got guards and gates throughout the halls, protecting against the attackers or intruders. This layer is all about ensuring that our applications are built using secure coding practices and they themselves are secure through regular updates, patching, and rigorous security testing to keep out the malwares and hackers. Then your most valuable possession, which is your treasure, is kept inside a safe room or a vault with a lock inside it. Similarly, data security involves encryption of sensitive data, ensuring that even if intruders get inside, they can't access or understand our treasure. And to access a specific part of castle, you need special access keys or passcodes. We need access control mechanisms like identity and access management or multi-factor authentication, ensuring that only authorized people have got access to specific data. And finally, our castle has got lookouts throughout its horizon, continuously watching for any suspicious activity. We use mechanisms like continuous monitoring tools, which are constantly scanning for any suspicious activity and ready to act at the first sight of the danger. And Nick will take you through all the mechanisms which we are using under the hood to protect our multi-tenanted AI service. And on top of these, we just don't want our services to be secure when we just launch them. We want them to be secure as the service team changes, people come and go, or our customer demand changes. So we want defense in depth. And in multi-tenant environment, the challenge intensifies. We are not just protecting a single castle, but a kingdom with multiple castles inside it. Depending on your tenancy model, each requiring its own set of defenses while sharing common set of resources and infrastructure. So as we have seen, defense in depth is like fortifying a castle layer by layer. And the same principle applies while protecting our multi-tenanted AI services, where each layer, whether it's a security layer, network layer, or data encryption, plays a crucial role in safeguarding data, operations, and ultimately our customers' trust. But building these defenses is just not like stacking the walls higher or digging the moats deeper. It's more about understanding who or what we are defending against. So to effectively protect our domain, which is our AI services or customer data, we must ensure that these we must ensure that we must understand our enemy, their strengths, their tactics, and how they might approach us. And for that, we need threat modeling, which helps us identify and understand the security issues and needs early in the development life cycle. By integrating threat modeling into our defense in depth strategy, it allows us, it just not only ensures the robust security, but also intelligently focus on most pressing threats which we can have. Let's look at the threats which we are protecting against. So before going through that list, I'll mention that this is not a complete list, but this is a good starting point for our discussion. So one of our main concern is the external actors who are trying to break into our system by testing every possible entry gate by finding a weak spot. They might be specifically targeting us or like you, our customers. Then we are also worried about number of insider threats. So the first one is witting insider. When people talk about this, they are referring to an employee who have got special access due to their job functions, who might misuse their power for their personal gain, or they believe in some cause, or they are actively working on behalf of third party. Then we are also worried about credential theft, where an outsider actor has stolen the identity of an employee and continuously working on behalf of them. In this case, the employee themselves are not malicious. Then we are also worried about our own team, who can accidentally weaken our security. This could happen as people come and go. or the people who made the decisions at the design time are not around anymore. For example, changes made by an authorized service team member just to take out new features out can actually make us more vulnerable. So we have to protect against these as well. This is called depth across time, across developers. Then we are equally focusing on making sure our software works the way it is supposed to be. This often involves looking out for the publicly available issues in our software, usually tracked in CVEs. Then, the issues in our own software. For example, there is not going to be a public alert for one of our own creation, like a specific part of Code Whisperer or Amazon Q or Bedrock. So we have to make sure everything which we build is safe and meets the security standard. And finally, the hardware failure. At our scale, even the rarest issues happen more often as you would think. And just by saying that this shouldn't have happened is not enough. We should be reliable even in the face of hardware failure. As I mentioned earlier, this is not a complete list, but this is just a starting point. Our goal is to be well prepared for these types of threats at any given point of the time. And the key takeaway you can take from our learning is that establishing your defense in depth strategy and identify the potential threats which you may have while building your next Gen AI application. And we have baked this defense in depth strategy into our wide spectrum of AI services like Amazon Q, Amazon Bedrock, Code Whisperer, etc. For the rest of the talk, we will use Code Whisperer as an example because we are talking about developers' productivity here. So how many of you heard about Code Whisperer or already using it? I see quite a few hands. Yeah. So we know developers often spend quite a lot of time writing the code manually, which is straightforward, like unit testing, string manipulation, etc. And on top of that, they need to constantly learn new tools and technologies, which keeps changing. This includes new programming languages to latest framework, or even your internal code repositories, your coding standards, APIs, etc. So to overcome that challenge, we launched Code Whisperer last year, which uses a foundational model under the hood that analyzes the comments in plain English text language right in developers' IDE and offer the real-time code suggestion. This way, developers can work faster and more efficiently and focus on more creative aspects of coding rather than bogged down by the basics. So during the preview, we ran a productivity challenge. Those who have participated in that challenge managed to finish their task 57% faster and with a 27% higher success rate as compared to those who did not. For example, Accenture is using Code Whisperer for their AI ML projects, and they have seen 30% productivity gain through it. By using Code Whisperer, they have accelerated the onboarding of new developers and spending less time on boilerplate or repetitive code patterns. In terms of security, they have enabled their developers to detect the security threats early in the development lifecycle by shifting security scanning right in developers' IDE. If you want to learn about their use case or how they are using it, you can scan this QR code, which takes you to the details of it. So after seeing how much quicker and successful work can be with Code Whisperer, we heard our customer wanted more. Our customer mentioned the need of Code Whisperer suggestions to be tailored as per their internal code repos, standards, APIs, etc. And customer also mentioned they are looking for a tool that not only understand the nuances of their work, but also align with their security requirements and protect their IP. That's exactly led to the evaluation of Code Whisperer. We launched the customization capability that allows you to securely connect your internal repos, which offers the real-time code suggestion based on your coding standards, APIs, etc. In terms of security, your code will never be used to train the underlying model, and your customizations will be fully isolated from each other within your account, from other customers, and the LLM powering Code Whisperer. For its under-the-hood architecture and its demo, I will invite Nick over the stage.
Thank you. Thank you, Deepika. Kia ora. My name is Nick Broadchoy, Senior Solutions Architect from AWS. So I'm going to talk about how we have applied defense in depth using Code Whisperer customization as an example. But let's start with a quick demo. So in this demo, I'm going to use a serverless web e-commerce application where you can find them in GitHub. And Code Whisperer customization will give you a score to help you make a decision on when to make this customization available. In your IDE, you connect to your customization. And for this demo, I want to add a coupon feature to drive the sales on my e-commerce platform. And you can see that it's able to complete few lines of code, and it's also following the naming standards that are present in my repository. Now let's add a validation function. So Code Whisperer can also complete a whole new function, including comments in line. So what did we just see? There are 3 key workflows in Code Whisperer customization. First is getting to your code securely. Second, indexing your code base. It's to make it into smaller chunks that's available to the model to, given context, generate your code base. And last is generating code for your developers. So these are 3 key workflows. I'm going to dive deeper into how we are applying security and tenant isolation patterns in Code Whisperer customization. So let's dive in. On the left-hand side, customers, that's all of you. And on the right-hand side is a sneak peek into security architecture of Code Whisperer customization. In the middle, I have put step functions, manage state machine and workflow service from AWS. This is there to just abstract away complex orchestration of many microservices that's sitting under the hood. And how this control plane is architected is not important for this session. So the users will ask to create a customization that will give us a name for the customization and a reference to their code base. And this repository can be in a number of different locations, or this could be an S3 bucket, which is an example I'm going to use here. So how do we securely access S3 bucket? So user could update bucket policy, granting access to Code Whisperer, could grant IAM role to Code Whisperer, but what could be a challenge here? The user may not have access to updating bucket policies and may not be familiar with policies. And in fact, this is way more access than we ever need. So how do we solve this? First, we have IAM, and we have Identity Firewall. Identity Firewall is not an AWS service, it's a microservice that sits inside Code Whisperer customization, and this helps us abstract away some of the security operations. When the customer calls to create new customization, these are sign requests, so the signature is attached. And we use this to go through a process called forward access session. This allows Code Whisperers to access your data only when there is a request from you. So let's carry on. So Identity Firewall will get forward access session, and it will call into IAM to validate its signature. And it will send through a profile. So think of profile as a IAM policy template. And these are defined by the service team, security team, and identity team. The point is that no single person can create a new profile for the service. And we also pass in the scope down policy. When we create profiles, we don't know which buckets and which regions we may need to access this data in. And scope down policy helps us to limit the access to a single bucket. As a result of this, we get a short-lived token that's restricted to a single bucket. And this is defense in depth and how token vending machine is applied. So now we have access to your code. Let's talk about indexing your code base. So we use OpenSearch serverless, and we use retrieval augmented generation. What does it mean? That means we do need to have a copy of your data, And access to this bucket is same as accessing customers' data. So we must protect this and minimize access. So how do we go about doing this? First, we use key management service. This gives you the control on how your data is encrypted. So you can specify KMS key to use, otherwise it will use a service on key. And again, identity firewall creates this operation, call into KMS, creating a grant, and this will show up in your CloudTrail log, giving you additional visibility into how your data is used and encrypted. So let's kick off the indexing workflow. So every time there's a new customization that's created, we create new collection in OpenSearch serverless. And this is an important design decision. So when you specify KMS key, all the collections that are created with the key will be placed in a separate compute in OpenSearch serverless, providing another layer of isolation. So let's continue on. We call identity firewall again, assuming a role with IAM. Again, doing a scope down policy, limiting it to single collection and single bucket. So if there is a developer mistake trying to access multiple buckets or multiple customizations, the architecture of the service will prevent this access. So now we have the code index. Let's talk about generating code. But first, we need to make sure the users are authenticated and authorized. And today, the permissions model in Code Whisperer customization is very simple. We have set of users who are authorized for customizations. But we know you, the customers, will ask for additional features, and there will be future complexities. And it is incredibly important, the permissions model, to work every single time, the way we expect it to do, and only the way we expect it to do. And similarly to OpenSearch serverless, we have made a decision to use another AWS service, Amazon Verified Permissions. So this helps you manage fine-grained permissions and authorizations for your application. It's like IAM for your application. And you can define its schema and policies using open source policy language. It has allows, denies, and deny trumps allows. And you can create a schema with a hierarchy of actions and resources that are relevant for your application and create policies describing your permissions. And even with the simple permissions model today, having the schema and policy that are separate from your application code base without conditional logic is great. Now we have user that is authenticated and authorized. Let's talk about model hosting service. So this is the hard path. Creating new customizations and indexing is an infrequent operation. Code generation is going to happen every day, all day, as long as your team are working. And again, we use identity firewall, using scope down policy, limiting it to a single collection and single customization. And when we connect to model hosting service, the firmware on the GPU is about the size of an operating system. And we have made a decision to bind each model into GPU core. So we're deciding that tenant isolation goes all the way down to GPU core. So that's great, but what happens if there is a confused thread? We use KMS encryption context. So it's set up key value pairs. These are not sensitive data. So please don't put sensitive data in here because it will show up in your CloudTrail logs. And the idea is that you have to provide same context when you encrypt and when you decrypt. So if there is a confused thread, it will end up generating wrong encryption context, access will be denied, and internal ticket will be logged. Now let's talk about humans that operate the service, all of us. So whether you are consuming number of SaaS services or you create and provide SaaS services, you expect level of employee access. For example, when something goes wrong, you expect people to be able to access to support and maintain the system. So how do we secure this access? MFA. Please show of hands if you're using MFA to access your services. See a lot of hands going up, that's great. Please use MFA if you're protecting anything of value to your customers or your organization. Us humans are terrible at picking strong passwords. We tend to reuse them. Please don't let your people do this. And the weak credential is easiest factor to get into a system. At AWS, we use hardware tokens. And we also invested in a mechanism called mechanics. This turns principle of least privilege into a mechanism. It has a predefined set of actions, parameters, and sensitivity classification that may require additional approval to perform an action. And what about a witting insider? We have a process called contingent authorization. The idea is that no one in the organization had persisted access to the system. You either need to go through systems like mechanics or provide justification and evidence that requested access is appropriate. So for example, this could be a customer support case, pager ticket, etc. And we have a system called Chronicle that logs every command and activity that happens in the system, and it gets streamed into another system for summarization and anomaly detection. So it would be very challenging to masquerade as me. You will need my credentials, my hardware token, and a device passing security posture checks. And you will still need to convince my colleagues or my manager to do what you want to do, and it will get logged and alerted. So what do we talk about? So we talk about broad definition of death. We talked about hardware, architecture, services, people, and mechanism. We know all of you are doing what's best for the customer, but we know over time things tend to fail. And all of these mechanisms helps us enforce tenant isolation across the life of the service, no matter who joins and leaves your teams. And as you scale, you need mechanisms. And this is combined with culture. Using systems like mechanics is baked deep into our DNA. Getting broad or persistent access is the last thing that any one of us wants to do. And lastly, it has been a journey. None of these systems were built overnight. If you don't know where to start building with defense in depth in mind. Our agility to launch new services and features is a result of years of investment in these mechanisms. If you want to find out more about Gen AI or security services, you can visit Skills Builder. Thank you for joining this session. Please complete the survey to help us improve. It should only take you 30 seconds. In step 2, there's a link to the session QR code. And if you enjoy this session, if you learn something new, please consider giving us a 5. Thank you.